This is Greg Troutline with Offshore Engineer TV, and we're very pleased to be joined today by Barry Parsons, the Group Chief Commercial Officer, Acteon, to discuss the challenges and opportunities inherent in the birth and growth of the offshore floating wind. Barry, to start us off, I'm sure most people watching this know the Acteon name, but can you give us a by the numbers look at the company using the metrics of your choice?
Yeah, sure. So we operate a global footprint. I think at last count, we're in 104 locations in 21 countries around the world. We're a head count of around 2,200 these days, 600 to 700 million US revenue, thereabouts, varies from year to year. We're set up across 3 operating divisions. We operate in data and robotics. They specialize in data acquisition, interpretation, and data delivery to the customer. Second division is called engineering, moorings, and foundations. We focus more on the marine construction activities. And energy services, they support the late life extension, decommissioning services for our offshore customers. But the connecting DNA is that we provide services to marine infrastructure. A lot of services. We provide services to assess, design, build, install, inspect, maintain, remove the infrastructure, but for us, it's all about the marine infrastructure. That infrastructure base today, of course, the installed base is all about oil and gas. That's where I grew up. That's changing quickly. Now, though, at the last count, the offshore wind installations are growing at around 22-25% annual growth. So that's happening fast right now in the business. Back to numbers, our track record, I think, is pretty substantial. So we've installed around 2,500 offshore wind turbine foundations so far to date. We've supported something on the order of 1,500 or more mooring spreads offshore, 800 or so drilling campaigns, and more than 300 decommissioning projects.
I know we're here to talk ostensibly about floating wind, but just to kind of give us a base to go on, as you know better than I, interest and activity surrounding the development of offshore wind, is growing globally. Can you put in perspective the opportunities that you see for Acteon today in the offshore wind market as a whole?
Right, kind of think about that in 2 halves. I mean, it's core business for us now. So around 25% or so of our activities today are outside oil and gas, the predominance of that driven by offshore wind, and that's growing. The challenge is importantly different in offshore wind. If you think about a typical oil and gas project, the focus is getting it right and keeping everybody safe. In offshore wind, that changes a little bit. The safety focus is exactly the same, but we're not installing one of something. We're installing dozens or sometimes hundreds of something. So that notion of cycle time and repeat and efficiency, it gets a focus that really drives the commercial value in offshore wind. That's a little bit different from oil and gas. I think, though, the next stage, sort of getting outside kind of where we are today with a lot of activity in fixed bottom wind, is going to be really around technology development. Even for some of these applications that are still a few years away from us, the technology development process is already truly underway. And really that's about taking technologies or techniques that are really well established in other applications and tailoring them to the offshore wind farm. A couple of technological challenges that spring to mind in fixed bottom wind. For years, all of the monopiles that have been driven are sort of 8 meter or less in diameter. Now we're talking about 12, maybe 14 meter diameter monopiles. Developing a technology to be able to install those doesn't exist right now, so someone's going to have to figure that out. So we're working on that. Cost-effective anchors. We're talking about floating wind now. Taking an anchor solution that's really well proven, but getting that inside a cost container that's suitable for floating wind is going to take a lot of work. And as we continue to sort of find more and more challenging soil conditions in installing offshore wind farms, finding faster, more reliable ways to obtain the geotechnical samples that we need offshore is an increasing area of focus. So something that we've been working on for the last couple of years.
The fixed bottom offshore wind is the play today, but most see that floating is the future. Mm-hmm. How do you see floating wind growing in the coming 5 to 10 years?
Yeah, I think it's inevitable. I guess like any industry, the industry is going to be driven by the resource that they're seeking. So in the case of an offshore wind farm, it's that wind resource that you're seeking. That's what drives the whole value food chain. I've read somewhere, I don't recall where, that around 80% of the offshore wind resource is in deep water. And so that means deeper water than you could practically install a fixed bottom installation. So you're talking about a floating hull. And clearly, I mean, offshore power generation is not the only use of offshore real estate, right? We're competing with fishing industries and transportation. There are protected environmental areas, and all of that complexity definitely increases as you approach the coast. So on the continental shelf, Whereas in deeper water, I think maybe there's an opportunity to deconflict and kind of respect those other applications that other users have for the subsea, for the seabed real estate. I think for floating wind particularly, it'll probably be something like 2026, maybe even 2027 before you start to see a real high inflection in the volume of the installation activity for floating wind. But I mentioned before that technology development conversation is already moving at pace. We've got commercial agreements in place for floating wind projects in Korea, in the UK, in the States, in France, and Norway, and Italy. I mean, this is not a small kind of maybe thing. This is big, it's global, and it's happening right now. And I think maybe some people are sort of if I can be blunt, maybe a little bit asleep at the switch. They're sort of thinking about this is later. This is tomorrow's problem. This is today's problem. The installation is going to happen tomorrow, but figuring out how we're going to do that is happening right now.
You know, I know you've talked about some of the Acteon capabilities already, but specifically, how do the experiences and capabilities of Acteon fit into this floating wind future?
You won't have a very many floating wind conversations that don't very quickly get into the complex supply chain and logistics puzzles that we're going to have to solve. Quayside facilities are going to be at a premium, managing enormous volumes of chain and anchors and hardware and hulls, and that complex logistics and supply chain challenge is going to be significant. We've got a fairly substantial track record over the decades of managing reasonably complex logistics and supply chain ourselves. So I think that's going to matter. I think it's going to help. Specifically, though, for floating wind, the mooring system is where a lot of the value and complexity and cost, frankly, is tied up. And so the notion of connecting, within Acteon, our stable of services, we can connect the geophysical survey to select the geotechnical points of interest, acquire those samples, do that analysis, and recommend the right mooring system, the right anchor solution for the best performance and cost for the project. In fact, we've got 2 agreements with offshore wind farm developers of some note to take sort of established, tried and true mooring systems, anchor solutions that were developed by us over the years for oil and gas, and take them and tailor them to this specific floating wind requirement. I think one thing we are starting to see, I'm really encouraged by this, is particularly with floating wind developers, a lot of early engagement from the developer customers. I think they keenly recognize the technical challenges and the cost challenges that this industry is up against, and getting up that curve is going to determine the winners and the losers in this space. And so I'm seeing more customers moving earlier. In fact, we just had one customer recently for a floating project in the UK. Typically, customers would procure the geophysical survey first. They go out, they acquire the geophysical, they take it away, they figure it out. Then they acquire the geotechnical service, and we go out and take samples. This customer's done it differently. They've engaged us early enough that we're going to deploy both, one sort of chasing the other. So the geophysical does the initial acquisition. We outline, select the geotechnical acquisition sites, we acquire those geotechnical samples, and then we cycle. Then we're back in the field with geophysical. The idea to really drive some efficiency, and that engagement's been really fantastic with that particular customer.
You kind of hit upon it before, the transfer of technologies being used in oil and gas. And, it's common for us to report on how technologies used in the offshore oil and gas space are being leveraged for offshore wind. But can you discuss how floating wind is effectively helping to foster some new technology development?
For sure. Yeah, look, I mean, I think like any new space like floating wind, particularly a technically complex space like this, a collaborative approach is always going to be the winning approach. So, developers and service companies and tier 1 contractors sort of working together to develop. And so I guess our engagement really started at a very early kind of concept stage with hull designers, hull manufacturers, and developers on that pre-feed work, looking at assessing the design of floating hulls, the dynamic behavior in the water, and thinking and making recommendations to them very early about that kind of high-level mooring and particularly cable installation considerations. But there is some sort of blank sheet of paper, new technology development going to need to happen, either driven by straight up technical needs, or sometimes more often, frankly, cost needs. We've got 2 specific developments that are underway right now. Both one's been granted a patent, the other one, that patent has been applied for specifically to provide a way to provide tension in those mooring legs for offshore wind installations that don't require another big expensive vessel and a lot of expensive equipment left in the water. Fundamental difference from oil and gas applications, which tend to be either very short term in the case of a semi doing a drilling campaign, or even for an FPSO that's just there for a number of years. These mooring installations are effectively going to be permanent, operating for decades, and so reducing the value of the equipment in the water is really important. And secondly, around the anchoring solutions, finding really clever ways that we can reduce the cost of the anchor and leave the developer with a lot of flexibility about the way they install that anchor based on the different soil conditions that they find in the field. I think those two are probably the most interesting for me from a technical perspective.
You know, every industry today is facing challenges, and much on it is premised, as you already referenced, by inflation and supply chain bottlenecks. When you think about it holistically, what do you see as the chief challenges to growing the floating wind business in the coming years?
Yeah, there's two. You already mentioned that, the notion of supply chain complexity, particularly at this scale. And the second that I'll come back to is sort of there's a lot of variability. We're early days right now in this sector, and there's a lot of variability I think we need to work through. So on the first scale, we're talking to one customer who's got a floating wind project that they've proposed with 200 turbines in the project. So if you figure 200 turbines, give or take 4 mooring legs per turbine, we're talking about 800 anchors in a single project installed over a couple or a few seasons. That's years and years and years of anchor installations in oil and gas, and we're going to do this in kind of one go on one project. Just think about the amount of chain and anchors, and never mind all the hulls at quayside. The complexity of just managing all that feed, it's going to be enormous. I think, though, behind that challenge is also a really important opportunity. A lot of this equipment historically, more and more over the years, has been fabricated far from where the project's going to be installed. I think driven in part by our regulators, but also in part by practical economics, it's going to make a lot of sense to fabricate more of this equipment closer to where the project's being installed. Generates a lot of local value in the local community. And this is not terribly complicated to fabricate, but there's a lot of it. So doing it locally, I think, is a real opportunity in the business. Reducing cost and carbon footprint is always a challenge. This has sort of become a bit of a cliche, I suppose, these days, but it's true, and it never goes away. A couple of challenges we're particularly working on right now is to reduce the cost and amount of people and big heavy vessels in the field. We're testing some autonomous surface vessels to let us do twice as much data acquisition for half of the carbon footprint. We're in the process now of commercializing the next generation of our seabed drilling and sampling robot. We call it Prod 5, specifically to increase productivity and cut costs, targeted really at offshore renewables. I mentioned variability. That's the second challenge I see, particularly in floating wind. There's somewhere over 80 different competing floating hull designs that are in the race right now. We're going to need to work through that variability. I think standardizing to some degree, at least in the market, is going to drive a tremendous amount of value. Standardization isn't always easy to come by. We know from decades in oil and gas where we all like to have 74 mil on one project and 82 mil on the next project, and that seems to be really important. But I think standardization in this cost, in the cost profile of a floating wind project, is going to be critical. Variability of soil conditions. We're in deep water. We're far from shore. We're exposed for logistics. Working through all that variability and finding really sort of specific custom solutions for these projects is going to be critical to drive value and cost-effective performance.
Okay, Barry. Well, again, I appreciate your time. I look forward to working with you and your team as this market continues to evolve over the coming years.
Likewise, looking forward to it. Thanks for the time.